In this video, we're going to take a look at the idea of compound interest. If you invest $1,000 at 10%, the idea of compounding, if we compound every year, the interest amount gets added at the end of the year and becomes part of the amount that earns interest. So if we start with $1,000, we can calculate 10% of that, we get 100. Adding that to 1,000, we get 1,100. That amount, 1,100, becomes the new amount at the start of year 2. So when we add interest at the end of year 2, we take 10% of that amount, $110, and we add that to 1,100, so we get 1,210. And that becomes the starting amount at the start of year 3. The interest amount is $121, and at the end of year 3, we get 1,331 in the account. And again, that amount is now the amount that's earning interest during year 4. 10% of that is 133.1, and adding those two amounts together gives us $1,464.10. And that's the amount that's earning interest during year 5. I encourage you to pause the video and complete the last 2 rows of the table on your own, and then we'll take a look at it together. So now in the last 2 rows, we see 146.41 as the interest amount. If we add that on, we get 1,610.51 cents. That amount, 10% of that is 161.05, rounding off that extra little 1 at the end. So the final amount at the end of 6 years of compound interest, we have $1,771.56. But more important than just being able to do this calculation year by year by year is a pattern that evolves. Notice what we can multiply by to get from 1,000 to 1,100. We can multiply by 1 plus the interest rate. So to get directly to 1,100, I can multiply 1,000 by 1.1. The first 1 represents the $1,000 moving forward to the future, and the 0.1 is the additional 10%. And using the same idea, we can multiply 1,100 by 1.1. But 1,100 we just calculated from 1,000 times 1.1. So if I multiply that again by 1.1, it would be simpler to just say 1,000 times 1.1 squared. So to get to the end of year 2, the amount in the end of year 2, I can take 1,000 times 1.1 squared. And then in a similar way, to get to the amount at the end of year 3, we can multiply 1,000 by 1.1 raised to the 3rd power. And now let's jump ahead. What do we have to multiply 1,000 by to get to this amount at the end of year 6? 1.1 is my growth factor, and it's been growing for 6 years, so I take 1,000 times 1.1 to the 6th power. So this actually gives us a very powerful tool. We're able to calculate the amount in the future without calculating all of the amounts along the way. In this way, we're representing the growth of the investment over time as an exponential function. It's a special type of exponential function called compound interest. And it leads to the following formula. So let's dig in to this compound interest formula, which represents the amount of an investment as an exponential function over time. So the initial amount of the investment is called the principal. Sometimes it's referred to as the present value. It's the value P here. The interest rate is represented by R, and we express that as a decimal. Here's something we didn't see in the first example. M represents the amount of compounding per year, the number of times the investment is compounded, the number of times interest is added on, and the exponent becomes M times T. So there are some traditional values for M. We can think of daily compounding, in which case the number of times per year would be 365. Weekly compounding, we would take 52, since that's the number of weeks in the year. Monthly compounding happens pretty often, and so M would be 12. Quarterly means 4 times per year. Semi-annually means twice per year, and yearly, of course, would just be 1. Now, I think looking at the following examples will help us see how all of this works. So I recommend, from the text, identifying the different values from the formula. If you deposit $5,000 in an account paying 9% interest compounded monthly, how much will you have after 5 years? So there's actually 5 variables in our formula up above. We have A, we have P, we have R, we have M and T. So A in this case is unknown. That's the future amount that we're looking for. How much will you have in the account? The initial amount is $5,000. The interest rate is 9%, so as a decimal, that's 0.09. M comes from this keyword monthly, so we're compounding 12 times per year, and of course the time in years is 5. So our calculation is going to be A equals 5,000, 1 plus 0.09 divided by 12, and then we get 12 times 5 as the exponent. So to describe a little why this formula works the way it does, the interest rate is an annual interest rate. It's expressed as an annual number, but we're compounding every month. So we don't get the whole 9%, we just get 1/12 of that 9%. So that's why this number here in the formula gets divided by 12. But then over 5 years, there are 60 months within 5 years, and so the exponent becomes 60. So if you enter this carefully into your calculator, you should see $7,828, and then after the decimal, it's 405. So I'm going to round that to 41 cents because the 5 causes the 0 to round up. Now, I encourage you to try this second example on your own, and we'll take a look at it in a separate video.